Hi, welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about industrial automation, IOLink, smart sensors, and Industry 4.0. I have Udo Fugar from Rockwell today to join us. Hi Udo, would you like to say hello to Design Spark?
Yeah, hello everybody. Welcome also from my point of view. And my name is Udo Füger from Rockwell Automation. I'm the EMEA product manager related to sensing connectivity business. And yeah, also welcome from my side.
Great. Yeah, it's really good to have you today. Obviously, industrial automation, it's a big area, and there are quite a lot of different technologies within that area. But one of the ones I want to start talking about is IOLink, communication method used for connecting smart sensors and devices to control environments. How can you explain how IOLink communication works? How does the data flow between the sensor or the device up to the for example, the PLC level?
Yeah, exactly. Well, first of all, with having IOLink now as an official worldwide open standard, it's the IEC 61131-9. It's a way to get, let's say, standard sensors connected to a network. And that's really what you want to do today. Looking at Industry 4.0, for example, you want to have all your devices connected to a network. And you know, the challenge for standard devices, standard sensors was always, hey, they just do an NPN or PNP output. So you just get a yes or no in a sense. No? And with IOLink, it's really getting the data over to a PLC, to a network, or providing the data of a device, and also give much more visibility into a device and say, hey, how good is this device working right now actually? No? So we see really diagnostic data, alarms and events from a device. And you wanna have data-enabled devices to make Industry 4.0 happening. And really, I would say this whole thing, smart sensors, smart devices, are the foundation of creating smarter machines and smart manufacturing. So coming back to IOLink, how does IOLink help here? Is really first of all, the way we connect a standard sensor is the same way we have done it before. So it's a standard 3-wire connection. You have your plus, you have your minus. And this pin 4 is then actually the way we communicate with that device. So either if there is no communication, then you just getting the discrete output. If there is a master behind, an IOLink master, we call this, then you will get the data over that pin 4. And so gives the maximum one flexibility, gives data enablement. And then what is really key from a PLC perspective is we are getting, of course, the we call it process data of a device, but we are also getting diagnostic data and all the other information. So that's really how it works. And again, it's a pretty straightforward connectivity. No change of wiring, no change of a cable required. Just a standard wiring.
Okay, so there's quite a lot of benefit for IOLink over the old analog style devices and data exchange methods as well. So one of the other benefits I believe is that you can just actually take one sensor out, replace it with another. Are there any other, and it will work just as you expect it to work? There's no kind of reconfiguring. But are there any other advantages between the older methods of data exchange?
Yeah, I mean, if you look back to the old days for analog devices, for example, for analog devices, all those hurdles going away in picking up the right analog digital conversion card, for example. Then if you think about the analog devices in the old days, you need to scale those devices to some shift and span things. You need to make sure you have the right bit resolution on your I/O card and all these things. So all this goes away, and of course there's a big saving on top because you don't need those analog digital conversion cards anymore in a PLC.
Yeah.
So from that point, pretty straightforward, and there's a big saving. Also, no worries about signal to noise issues. Now, simply the digital coming from a IOLink device is already digital. So all those things going away and make life easier, I would say.
Yeah. Is IOLink becoming the dominant method for extracting data from sensors? You were talking about process data and diagnostic data. Is IOLink becoming the dominant force, or are we already there yet?
Yeah, absolutely agree on this one. And IOLink, I would say, is right now the fastest growing technology in the market. we see so this curve is really ramping up now. There's I would say round about always close to 30% CAGR we are looking at. We have right now round about overall in that market, we have over 15 million masters in that market. So if you think about a master allows you to connect between 4 and 8 devices, you see easily we have over 100 million devices already in the market. And this goes aligned with a lot of new device manufacturers. So we think about around about 100 device manufacturers we have in that market, and over 20,000 product IDs are in that market. So if you look at the pure numbers now, we can say, hey, this is really evolving, and this is really, we are already there. And some customers, they join later. You know, we have always the early adopters in that market space. They are on that technology already since many years now. And but every year we see new OEMs coming on that technology, you know, more or less. No?
Yeah. So in terms of the reduction in cost that you kind of touched on there, because obviously we don't need as much of the product infrastructure behind the application. Is it the reduction in cost is one of the main driving benefits, or is it a combination between the actual operability and the reduction of costs? Because I guess there's probably a lot of retrofitting gone on out there with IOLink devices when customers are looking to retrofit their applications.
Yeah, exactly. There are many points actually, and just let me share briefly a slide. Just share my desktop here for a moment. First of all, here what we see there are three areas really. First of all, if you're looking at predictive maintenance, that's one of a key driver, because now having those diagnostic data or signals embedded, we know exactly what is ongoing in a device from that perspective. So with that information, actually, for example, if a margin level is going down, or let's say a signal strength data is going down, we know exactly, hey, something is happening on that machine. If we contextualize those information, and then we can provide that information to an operator and say, hey, dear Mr. Operator, go on that part of the machine, go to that sensor and clean that sensor before we run actually in a machine stop. So preventing machine stop, that's actually a key thing we are looking at. We don't want to stop any machine unplanned, because all the costs goes aligned with a machine stop is the loss of production and so on. And we want to make sure we keep the OEE of a machine up and running. Always good OEE performance, overall equipment efficiency data. And so predictive maintenance is one thing, but looking at the other two bullet points here, production changeover is a key area. For example, if you think about a food plant, a packaging line in a food company, they do multiple changeovers per day. Sometimes could be 3-4 changeovers. So production changeover, product A to product B. Now with IOLink sensors, what you simply would do is you download a recipe of new parameters into the device, and you are ready to go. No, there is no go around the machine teaching the sensors and so on and so on. So here, really just download a new recipe of parameters. So also this helps dramatically to increase overall equipment efficiency. And then the third bullet point here with the sensor replacement, actually, think about, you have to replace a device on a Sunday night shift. You don't have the expert on a machine. That's normally how it happens, really. So with an IOLink device, what you would do is simply connect your new device, and then once connected to the Logix architecture, we are simply downloading the latest set of parameters into the device. We call this in Rockwell the ADC functionality, so auto device configuration. So that means here we are also reducing machine downtime dramatically, and helping to get the machine up and ready soon. So those are really cost drivers, I would say, and we are saying with smart sensors in general, we can have a productivity increase by 15 to 30%, depending on the industry.
Obviously, what you were saying there with the production changeover, there's a lot less time involved in that, and you can have a new line up and running quite quickly. But then also, if there is any untoward damage, maybe for a sensor, and you need to replace the sensor, then that's just a quick, simple process of swap one in and out, and you're good to go again. So my next question was actually going to be, what would be the the advice you'd give to someone if they were looking to start a new kind of project using IOLink devices?
Yeah, really, I think the key thing is having Industry 4.0, smart manufacturing, and all these things coming up. I would say make your machine future ready. I think that's the key message. Make it future ready. You don't know what will happen in the future, and with having, for example, an IOLink master embedded right at the beginning of your architecture, you make sure you can connect always later on IOLink devices, if you want. So that means you don't have to plan everything right now on IOLink. We have many customers, they still have, let's say, conventional devices in their machine. Maybe they are not all on IOLink so far. Maybe that could be one reason. But nevertheless, you place your IOLink master and you're ready to go, because on a IOLink master you can also connect standard devices if you want. Just a matter of configuration. So make it future ready, and then you are prepared for the future. And for me, we have many customers, many OEMs. It could be a little bit, I would say they're always cost concerned. They think about the cost of a machine. But if you think about from let's say from an end user perspective, if you think all the big end users, they know already the value of IOLink and smart sensors. So they know the value and they are willing to pay maybe this extra charge we are looking at, but they are willing to pay for it because they see the benefit of savings on what they have on their machines, on their production lines. So yeah, I would say don't wait. Maybe start small and build your way up. I would suggest.
Okay, so in terms of support that Rockwell give to users, how easy is it to connect and configure IOLink sensors using your Logix platform? But also, could you just tell us a little bit about Studio 5000 Designer from Rockwell?
Yeah, exactly. The Studio 5000 is our design software, and really what we say or what we do really with IOLink devices is we call it, they have a Premier integration into the Rockwell world. That means once connected to a network, to the Logix controller, we configure all those devices with one common software, which is Studio 5000. So that means what you simply would do is either the Rockwell devices are already preloaded. If not, you upload your add-on profile. We call this in Rockwell. It's a profile, comes with a device, and you don't need to program any interfaces here. It's just you load your add-on profile, and you are ready to, let's say, configure the devices. Now, that's a pretty straightforward way of doing it. And for third-party products, it's also possible. For third-party products, you would simply upload an IODD file. IODD file is what we have in the Rockwell world as an EDS file. So it's a file which comes with the device and with all the data and all the parameters. And for third-party devices, it works the same way. You would upload your IODD file and you're ready to go. So pretty straightforward.
Udo, is there any kind of typical use cases that you could share with us with IOLink sensors in machines?
Yeah, exactly. There are multiple use cases, and I think a very common one is production changeovers on a machine. Having multiple changeovers on a machine, this is ideal for recipe handling in the controller, having everything preloaded in the controller and do then your changeovers. But also device replacements, as we briefly talked about. The ADC functionality, for example, is a key use case. I would carry on with commissioning a new machine. Think about you're getting a new machine into your plant. It's really easy today in let's say go around of that machine with a mobile device or with an iPad, whatever you call it, and then you simply do your readjustment of the parameters of the devices. So also here IOLink helps very good. Predictive maintenance is a key use case for IOLink, because having now all the different parameters. So just to give you an example, for most of for the electric sensors, we monitor how good the signal is we are getting back from an object, for example. So let's see, you have a signal strength data. This explains about how good the signal is we are getting back. If that signal is going down over time, that means, hey, something's happening on the machine. Could be either the sensing distance has been changed. Somebody changed the material or something, or the color of a material. Yeah? So it gives you an indication something's happening, and you can really react in advance and say, "Hey, please check," and before we are running into a machine stop. But also temperature control. We do, for example, for most of the devices, we measure the internal temperature. We also give information about the location of a device. So that's very important. We should think about, you need to do something on a device, have a big, large machine, 20, 30 sensors on a machine. All those sensors, they look pretty much the same, more or less all black colored devices. So from that perspective, with location indication, we will flash all the LEDs on a device, and with that optical indication, you know exactly where to go and where to replace a device or to do some changes on a device. So this is a very useful features, I would say. And I would say in general, the troubleshooting becomes much easier. Nah? If there is a miswiring, we can easily identify this one. Or if we are losing a heartbeat information for all of our devices, we do heartbeat information. That means for a photoelectric sensor, it would be the LED. We monitor the LED if the LED is working. For an inductive sensor, that would be the coil, for example, if the coil is still working. So those heartbeat informations are really key. If you are losing a heartbeat information, that's something, hey, something is going on. Go there, replace a device, and so on. So also from that perspective, troubleshooting is much easier because you know exactly where to go and what to do.
Yeah, that's kind of a really interesting point there. That in itself will save you a lot of time, resource, and obviously money at the end of the day. So in terms of the data, we're talking process data, we're talking diagnostic data, and troubleshooting with IOLink. So Udo, I'm just interested to discover a little bit more about the types of products that Rockwell offer with IOLink technology. Are there a couple that you would highlight and maybe just give us a little bit more background around?
Yeah, absolutely. And I would like to share another slide here. Just let me know if you can see. Hopefully you can see the slide here.
Yeah.
That's just a high-level overview. I think, first of all, we do all the different technologies, sensing technologies. So there are around about, we are doing 18 different families, different series today. Across all sensors, even it is a photoelectric sensor, inductive sensors, but also ultrasonic, pressure, temperature for process-oriented control, but also RFID and so on. Recently, we added tower stack lights. We do circuit protection. And what is really important, we also do the different masters. So from that little architecture drawing here, you see we have basically two types of connecting devices. So first of all is an in-cabinet solution. That means we are having the so-called point IO architecture here. You would wire back everything into a cabinet. No? Or the on-machine connectivity. That means the IOLink master is an armor block version, IP67. You would wire everything directly into that master here. Or the hub structure is very common. There you see on the right-hand side this little hub. If you have a mixed installation on your machine where you have, let's say, you have IOLink devices, but also non-IOLink devices, you could collect everything together with a master and a hub structure. And this makes you extremely flexible, and we are making sure we are collecting all the sensors on that machine. So again, from a portfolio offering, we have a very broad offering today, and of course this continues, and we are adding many more families in the future. But today there's already a very good coverage, I would say.
Great. And I know RS are bringing some of these products on board as we speak at the moment as well. So what we'll do is when they're available, we'll create a couple of links to those products as well.
Absolutely. So, yeah, I think we are working in the background of adding those things.
Great. Udo, it's been fascinating talking to you today, albeit very short on a big subject, IOLink and smart sensors industry 4.0. But I really thank you for your time today and explaining a little bit more about the technology, and so we can understand the products, the application of the products, and how Rockwell are obviously helping to support customers to deliver IOLink applications in the wide world. So thanks for your time, and I hope we see you on Design Spark again sometime soon.
Thanks, Greg. It was a pleasure talking to you. Thanks.